Hi student, what's up? In the previous class, you learned how to solve a pair of linear equations. Today, we will learn the type of solution it can have. At first, let's solve this simple pair of linear equations. X plus y equals to 5, this is the number 1 equation, and x minus y equals to 1, this is the number 2 equation. Let's find the value of y in the form of x in the equation 1. It is y equals to 5 minus x. Now, substitute this value into the equation 2, we will get x minus 5 minus x equals to 1, implies that 2x minus 5 equals to 1, implies that x equals to 3. Substituting the value of x into the first equation, we get y equals to 5 minus 3 equals to 2. Here we have got an unique solution. Let's see the graphical approach. At first, make a table of y values for different values of x. In the first equation, substituting the value of x equals to 0, we get y equals to 5. Similarly, for x equals to 5, we get y equals to 0. Similarly, for second equation, for x equals to 0, y equals to minus 1, and x equals to 1, y equals to 0. Here, this straight line is representing the first equation and this straight line is representing to the second equation. So, the common intersection point 3, 2 is satisfied by both of the simultaneous equation. So, it is the solution point and it is the only unique solution. Now, look at this example. 2x minus y equals to 1 and 4x minus 2y equals to 2. Solve this equation similarly by algebraic method at first. By substituting the value of y equals to 2x minus 1 from equation 1 into equation 2, we get that 4x minus 2 into 2x minus 1 equals to 2, 4x minus 4x plus 2 equals to 2. So, here 4x gets cancelled and we are left with 2 equals to 2, which is true for all values of x. Therefore, we get corresponding infinite values of y. So, it results that we get infinite solutions here. Let's analyze the second equation. If we divide both sides of the equation by 2, we will end up in the first equation. So, these two equations are equivalent. So, we have only one linear equation with two variables. So, it will have infinite solutions. Let's have a look at graphical method. For the first equation, putting the value of x equals to 0, we get y equals to minus 1, and for x equals to half, we get y equals to 0. Similarly, for the second equation, we get the same points of first equation here, which is for x equals to 0, y equals to minus 1, and for x equals to half, y equals to 0. So this straight line represents both of the first and second equation. So, they have infinite common points between them, or we can say the simultaneous equations have infinite solutions. Now, look at this example. X plus 2y equals to 2 and 2x plus 4y equals to 6. Solving algebraically, we get y equals to 2 minus x by 2 from equation 1. Substituting this value in equation 2, we get 2x plus 4 into 2 minus x by 2 equals to 6. Implies that 2x plus 8 minus 2x equals to 6. Implies that here 2x gets cancelled and we are left with only 8 equals to 6, which is never possible. Since this is impossible, we can say there is no solution which can satisfy both of the equation. So, these two equations are inconsistent. Let's look at the graphical method. For the first equation, putting the value of x equals to 0, we get y equals to 1, and similarly for x equals to 2, y equals to 0. For the second equation, for x equals to 0, we get y equals to 1.5, and for x equals to 3, we get y equals to 0. Here, this straight line is representing the first and this straight line is representing the second equation. Here we can see these two are parallel lines, and we know parallel lines never intersect. So, we get never any solution for this equation. In the first two cases, we get solution. So, these are called consistent, and the third case is inconsistent. Now, there is an interesting method for determining the type of solution. For the general pair of linear equations a1x plus b1y plus c1 equals to 0 and a2x plus b2y plus c2 equals to 0, in the first case, if a1 by a2 is not equals to b1 by b2, then the simultaneous equation will have an unique solution and the graph will have two intersecting lines. For the second case, if a1 by a2 equals to b1 by b2 equals to c1 by c2, then the simultaneous equation will have infinite number of solutions and the graph will have two coinciding lines. For the third case, if a1 by a2 equals to b1 by b2 is not equals to c1 by c2, then the pair of equations will have no solution and the graph will have two parallel lines. We can verify this with our previous three examples by putting their values of coefficients and constants. In the first example, we see that a1 by a2 equals to 1 and b1 by b2 equals to minus 1. So, a1 by a2 is not equals to b1 by b2, and this is satisfying the first case. So, it has unique solution. In the second example, we see that a1 by a2 equals to half, b1 by b2 equals to half, and c1 by c2 is also equals to half. So, a1 by a2 equals to b1 by b2 equals to c1 by c2, and this is satisfying the second case. So, it will have infinite solutions. In the third example, we see that a1 by a2 equals to half, b1 by b2 equals to half. Now, we also have to check for c1 by c2, which is 1 by 3. So, here a1 by a2 equals to b1 by b2, but not is equal to c1 by c2, and this is satisfying the third case. So, it will have no solution at all. By this method, you can tell easily the number of solutions without solving. Interesting, right?